Okay, we can get started. Go ahead.
Yeah, sure.
Okay, you're so your host. So
Okay. So first of all, NATS it's a cloud CNF project. Okay, it's like a more and we are using in all the mostly in Kubernetes and certain places. Okay, you can take a look of what are the projects under that. It's like a project we have gRPC, we have NATS, and then we have HEM, and then we have EDCD, and then we have hardware along with that projects. Okay, along with the projects, it's like, and we have an open policy agent. Okay, along with that policy, okay, we have the NATS also. So it is grouped under a cloud native computing foundation project. So which mostly deals with that cloud problems. Okay, what are the cloud problems and cloud native problems that we are trying to deal, and then this kind of projects tries to solve that. Okay, what problem that we have right now? Okay, one important problem, it's like we need a mechanism to communicate. Okay, let me talk about one simple use case that where really that we need that. Okay, say for an example, we have one problem. Just 2 months before, we had one issue called the caching issue. Okay, caching issue, it's basically, say for an example, we have 3 replicas running together, and then say for an example, the first request comes into that for a blueprint processor action, and what it tries to create, it pulls that blueprint artifact information from the database, and then it tries to create a cache. Okay, for scripts and all those things, it tries to create a cache and retains it in the cache. Okay, as we all know that the cache is for better performance and faster way of accessing, retrieving that information. So we are trying to cache that information. Okay, say for an example, the first replica satisfies that particular case. Okay, the first replica, the first request landed into the first replica, so that it worked in that case. Okay, so it creates a cache. Now immediately what happens? Okay, there is a update in that particular CBA file. Assume that there is update in a CBA file. So that CBA, where you are trying to get that request in a second replica. Okay, the second replica, it means like it tries to first delete from the database, and then it tries to clean up that cache. Okay, first it tries to clean up the cache, and it tries to clean up the database, and it tries to clean up the file location path. Okay, and then it updates the newer version. Okay, this is the scenario. But the problem is like the first request landed in that first replica. Okay, we didn't clean. Okay, at that point of time, okay, it didn't clean that cache information for that blueprint processor. So whenever third request comes for this same blueprint name and version, okay, that is going to land, if that particular request is going to land in that first replica, then it uses that old cache. Okay, you understand this problem, right? So it should not be. Okay, so it means like what I'm trying to say, it's like we need to, whenever there is a delete request comes into picture, then the delete request has to be notified to that all the replicas, so that even if they have already cached that information, then you should delete all those information. Okay, now with that current architecture and then with the load balance architecture, we don't have a mechanism to automatically understand the neighboring or peers actually. Okay, peers or replicas. Okay, so that I'm not sure about whether they already cached that information or not. Okay, so that is a real problem, and if there is a if that is the case, then I want to communicate that. Okay, if one replica receives that if one replica receives that deletion request, then that deletion request has to be sent to all the 4 replicas also, so that we want to have a safer mechanism, safer clean caching mechanism. This is one example that I'm trying to say, but there are so many examples associated with that cloud native problems actually. Okay, I think I explained this problem. I think you guys are able to understand this scenario. If not, I will try to explain so that you can understand why we need this kind of architecture, right? Is it fine? You guys are able to understand that?
Yeah.
What? Okay. So what now that how to solve that problem? To solve that problem, we need a channel or messaging channel, okay, where particular message has to be sent to that all the replicas or all the connected application. Okay, what I'm trying to say, it's like it is not only the blueprint processor. Say for an example, you are having a resource resolution which manages the same resource template, but they are trying to use only the certain templates, right? And you are having another microservices which is handling the same CBA file, but with a different use case or different thing it is trying to sort out. So in that case, it is not only inside the same replica, it has to cascade to that multiple applications also. Okay, so it is not that easy. So we need an architecture, so where publish subscribe kind of mechanism, so where all those certain things it has to be work in a load balance way, certain thing it has to be work in all replicas, on all connected applications, and certain cases it should be work in a request reply fashion. Okay, another important issues that we have with the cloud issues like cloud and Kafka and other messaging system in terms of request reply pattern, it's like you can initiate a request from one instance, one replica. Okay, the target application, it may land into the target application out of 3 replicas, and the response, it didn't know where to send that or where to route that response. Okay, in a asynchronous fashion. In a synchronous fashion, it retains the connection so that it can return in a same channel, so that's not an issue. Even gRPC, we can retain in that same connection so that it can understand that which who is the host and who is that caller for the particular request, so that it can easily understand. But in asynchronous world, okay, if you want to have a loose coupling, okay, loose coupling architecture, very loose coupling architecture, and service bus kind of an architecture, if you are trying to build. So in our case, what I'm trying to look into that, each node, it should be a microservices, and then that microservices has to take certain messages, and it has to process in an asynchronous way, and it has to return back that response to the same caller, so that the context will be preserved, okay, for the further transactions. Okay, that is another use case. So it means like request reply pattern in a cloud, we need a certain mechanism or certain infrastructure to support that. Okay, in order to support the loose coupling, along with the loose coupling also. Okay, so I explained all these 3 different use cases that we want to solve in terms of a cloud native problems. Okay, so that everything it's NATS is trying to solve that. Okay, one is, and another important problem. Let me talk about that with respect to Kafka and other things. Okay, in order to create a topics. Okay, right now we are in that world to have a multiple subjects or multiple subscribers and multiple consumers, on fly creation of these subscribers and consumers. Okay, we are in that world right now. Okay, one good example, it's like for ORAN kind of project. So you may want to have the listen for a particular e-node kind of a configuration. So in that case, what's the thing is, you may end up with the 3,000 or 4,000, and then we want to queue that messages for a particular e-node B. Okay, so such kind of scenarios we may have that. So in that case, what's the thing is, what I'm trying to say, it's like we need a flexibility, or we need a mechanism to automatically create a subjects on fly, just by mere understanding that, okay, number of so that the sender can understand that what is the message, and then consumer can understand that, okay, I'm listening for this certain request, and along with that, it supports a queuing mechanism, it supports a back pressure mechanism. So many other functionalities or many other use cases associated with. So that kind of scenario not supported by the current or any of this architecture. Okay, like a Kafka. For that, now we need to have a separate provisioning process for each topic, and then management of this each topic. Okay, and moreover, we want to have a clustering also. Clustering concepts is like another issue that we are facing with the Atomics. It's like a clustering configuration. But NATS, we don't have to bother about all those configurations. Okay, NATS solves all those issues. Only thing is like, and even it has a fault tolerance, geo fault tolerance. Okay, all kind of capabilities that you can see it here. And then most of that, it's like a performance based. Okay, you have a very good statistics when compared to that Kafka and other thing, so that it can be used near to that edge very effectively. And along with that, IoT, mostly we can use it in an IoT perspective. It's like a more reliable and more performant way. So that's a use case. Most of the use cases, and even it can be even that log. Another important problem, it's like a log log cascading, right? So all those issues that we can solve with this kind of messaging structure. So in that case, we don't want to cascade all the logs to a single and then WebSocket. We don't want to have a WebSocket to consume for that logs with respect to this user ID. Okay, so in that case, we can create a subject with respect to user ID, and then from irrespective of any microservice, okay, they can send that message to that particular subject. Then UI can consume on the particular subject. Then based on that request ID, we can create a subject, and then we can consume the subject. So it creates a clear separation and a more efficient way, and then less coding, and then less maintenance perspective also. So all those things it is trying to solve. So you can take a deeper look into that, why we need this, okay. Just on a highlight, we need a subject-based mechanism. So this is a simple thing. So you can send a message, and then you can send that same message to that multiple consumers which is having the same subject. So it means, like in my case, if I want to clean a blueprint processor, so I will just want to consume that subject called blueprint processor cleanup. That's it. Okay, on all three replicas. Okay, since it is the same piece of code, common code which is sitting there. So in that case, the message will be sent to that all the infrastructure or all the subscribers at a time. Then it can work on that. Okay, and it has a publish subscribe pattern. It has a request to reply pattern, and then queue grouping. Queue grouping is similar to load balancing. Okay, so say for an example, out of 4 replicas, I want to get that message in only one replica. Okay, then that is called a queue group. It is similar to load balancing concept. So that is also possible. And then acknowledgement, manual acknowledgement. It's like a failure. Say for an example, you sent a message, and then I'm processing on that message. Then I will tell that I have completed that message. So it means then only it clears that information, so that it keeps tracks of this, or what are the messages it has processed, so that we can keep control of that messages and then process once, even at the failure condition. Once you recover back, then we can get back that, or we can process from that same message itself. So many features associated with that. Okay, that's the reason we are trying to use that NATS. Mostly the NATS, we are trying to solve the problem of multiple consumers with the same subject. Okay, that's a point here. Okay, so we have created a NATS. Okay, a NATS library. Okay, so we have created a NATS library, and then NATS library we have both streaming and a normal NATS. Okay, it's like a simple. Even the Docker image, it's like a less than 18 MB, not more than the streaming, maybe 36 MB, and the entire infrastructure of the NATS, it's like less than 20 MB itself. Okay, and the performance is high and completely written in Go, so you can check that. And we have created a services and then property based, and we have aligned that NATS with respect to our blueprint processing configurations and services kind of. And then you could see one example, or you can see that examples in the message prioritization also. We have showcased like one message prioritization with the NATS. So we can see that how NATS we are trying to, okay, NATS consumer, it is similar to the NATS consumer, we are trying to get that. So what I'm trying to say is like, with this NATS, the internal communication, even from one node or one microservice to another microservices communication, we can also use with the NATS also. That is another point. So in that case, we don't want to load heavily on the blueprint processor alone. Okay, we can have that multiple replicas, or internally we can manage that, or we can spawn up multiple microservices like command executor separately, and then even we can talk to that command executors and all those using that NATS. Okay, and so many use cases we can try to solve that also. Okay, with the point-to-point communication, and even one-to-multiple communications, and one-to-one communications with respect to load balancing. That's all I have. So any questions to me, so that I can talk further in that case.
Quick question: is there, because right now we're introducing 2 different cluster technologies, so Atomics and NATS. So is there any way that one can do what the other do, or vice versa?
No, that's the thing. Okay, so NATS, only thing is NATS doesn't support locking mechanism. So if you have a Go developer, we can develop that locking mechanisms in a NATS so that we don't want to bother about this kind of clustering configurations and all those things. That's what I earlier mentioned that. Okay. So for point-to-point
Okay.
communications, we can use very effectively with the NATS. Okay. NATS has a very, so in that case, if I want to send to a particular cluster members, I can directly talk to that particular cluster members and then I can expose that. That is possible with the NATS. Even that is also possible with the Atomics. Only the issue with NATS, it's like it doesn't have locking mechanism. By default, it doesn't have a locking mechanism. If you try to build that locking mechanism, if you have a normal Go developer, then we can build that locking mechanism. Okay, just it's like no, just we can expose a one subject and then we can expose the same data store, or internally itself we can build the same logic, right? Okay, just to tell that okay lock and then release a lock, but it is a little bit too complex. Okay, we want to understand, we want to release that lock and then client has to listen for that. Okay, that and all we can manage it, but it can be doable. That is the reason it's like it shares a common functionality. Some of the functionalities in terms of message communication shares a common functionality, but locking is not there in NATS. It is there in Atomics. But in Atomics, little bit configuration we want to do that, but NATS we don't want to do any single configuration. Only thing is like we want to tell that which NAT port that we want to connect. So automatically it creates a cluster. I think there are so many examples in YouTube. So you can see the geo clustering and then how simple it is a clustering. You don't want to bother about just only one endpoint. If you are able to connect to only one endpoint, you will have that entire visibility. And along with that, you can have accounts management also. So it means like, so for a particular subject who has to be a consumer, you can manage that also. Okay. So all those concepts are there. But only the disadvantage with NATS, it's like locking is not there. Okay. And I don't see that any other framework is supporting very good locking other than that Atomics. Atomics is best in that locking. Locking and distributed data store. Okay. Two important concepts. Atomics is best. So I think as a community
we want support pubs, but it doesn't support PubSub.
No, it supports that
PubSub.
It supports PubSub.
It does?
Okay, it supports a PubSub the same. It supports the communication also. But the problem is like it is not reliable as NATS in terms of a communication perspective. Say for an example, as we are trying to look into the configuration, right? So we want to keep concentrating on the configurations, and then suppose for an example, if a particular client it's under this subnet, okay. So sometimes we may not able to communicate from one network to the another network. Okay, in a geo-redundant kind of fashion, you can't try to communicate. But NATS it does very effectively. It doesn't bother about that. Okay, from one geo to another geo, from one network to another network, it can easily communicate. It can easily try to send that message. Okay, because NAT forms the cluster and the NAT understands that. But here, what's the thing is we want to create the cluster. That is another important point, right? So in Atomics, we want to create the cluster, we want to provide the configuration. Sometimes the configuration may be reachable, sometimes that configuration or sometimes the client may not be reachable. So that we are restricted in designing that configuration and design or grouping that particular clusters. Okay, but in NATS we don't want to do that. It has that full-fledged support and very simple.
Okay,
I think
so
I answered your question.
Understanding, yeah. So my understanding is, from what you're saying, Atomics can do PubSub, but the advantage of NATS is the fact that it can support geo redundancy.
Yeah. Geo redundancy, point to point, and request reply pattern.
Okay, so do you? It's just that it's a lot of moving parts for, in the end, at least from what I can see. I don't know what is the use case for PubSub beside the syncing for the cache.
Okay.
Are we going overkill? Like, are we going overkill with NATS just for potential? 2 seconds, just for potentially geo redundancy when we can just simply use Atomics for now, and it will serve the purpose we have for now. And then maybe integrate NATS later on.
The use case now we have a back pressure. Okay, the back pressure capability is one support by Atomics, right? So it means like I want to process a message one by one. So we need a messaging infrastructure.
Yeah, back pressure of what? Of telling all the node that the blueprint got deleted?
No.
I mean,
not only that. Okay.
So that's
for an example, we have
that's my question. What's the different use case beside syncing for, okay, this blueprint got deleted, then every pod needs to delete it?
Exactly. That's another use case that I'm trying to talk. Okay. So the use case, it's like I have 1,000 messages coming into that system, okay, continuously, but the device will take only one message at a time. Okay. So I need to hold that message. Okay. I need to put it in a queue, and then I want to hold that message. I will process that message one by one. Okay. So that is another important use.
But isn't that the use case for Atomics? You lock on a
No, that
device
is not
and then it's serial?
That is not use case for Atomics. Okay, that is a use case from load balancing perspective, the device load balancing perspective. So one way to solve that, it's like just we need a intermediate buffer. Okay, we need a intermediate buffer. Okay, and which should not load that microservice. The problem is like NATS can communicate from one cluster to one node to another node, but the problem is like the data caching, everything, that microservice has to handle that load, performance, caching, and all those things. But if you're trying to introduce a messaging channels like a Kafka or NATS in between that, so that offloads the buffering, right? It offloads that the performance and then the size of the data, and then failover once it's like a processing of the data. Okay, most of the things it's offload by. I think you know that advantage, the way we are using a messaging infrastructure. Okay, so that bus handles all those things. Okay, so that our application code and application, okay, information becomes very simple. Okay, in terms of just I will take one record at a time, and then I will process. Once I complete, I will take the second record, I will take the third record. Okay, so in that case, I can manage, because we are trying to talk about IoTs, and we are trying to talk about 5Gs. Okay, the number of requests, the configuration, it has to be sequenced, it has to be processed in a certain way, it has to be prioritized. Okay, so many things that we need a intermediate bus, okay, or a data store kind of an architecture. So where we want to do some manipulations, okay, and then handle back to that another channel. It may be a different microservice, or it may be a same microservice, and I want to connect that multiple microservice in a certain fashion, uniform fashion, so that it should be easily integratable. Okay, that is the only thing. And another important use case is like a network transparency. Okay, that is a part of a reliability use case perspective. Okay, network transparency. So it means like I can execute a certain process in a same instance, or I can execute in a separate microservice. Okay, so I don't want to bother about whether I'm going to execute in the same instance or a different replica or a different microservice. So in that case, underlying channels should support. I need to have a channel support for that. Okay, that channel should have a point-to-point communication, request reply pattern, so that the context can be managed, but that worker node should be distributed. So that is another important use case. Okay, whenever it comes into a performance perspective, okay, we want to solve that. So that's where it's like we need to introduce some messaging channel. Okay, that messaging channel, either it may be a Kafka or NATS, or it may be. So we are trying to compare that Kafka or DMAP or NATS. Okay, so which one will satisfy most of our use case?
Okay, I mean.
Okay, and it is a pure optional. That is another important point. Okay, this library is a pure optional. It is no need to have that. Okay, whenever there is a use case, okay, for this use case, because we have some use case for a message prioritization. Okay, so in that use case, we want to offload the data and then sequence the data and then send that data one by one. Okay, so such things. Okay, we don't have that any other infrastructure or any other logic or any other system which can handle that. So we need a messaging infrastructure for that. I think I answered your question. Okay, other than that caching use cases, there are so many use cases also.
Any other questions from the team?
I'm good.
Okay.
So maybe